Embedded processors are becoming dramatically more sophisticated, and in many cases that sophistication includes a variety of user interface devices. Let's look at how the Casio kDiagnostics environment has been enhanced to support these user interfaces. Here's the block diagram of a standard system. The kDiagnostics software executes on the embedded CPU of the unit under test and connects via a standard communication protocol such as serial, USB, or Ethernet to the Casio Validation Assistant running on a PC. Dr. Steve Schaefer, Casio's Chief Technical Advisor, will now demonstrate a sophisticated user interface test on a real platform.
Here we have a typical system with a variety of user interface elements. As is often the case, some type of display system is one of the key components. Let's look at how the Casio environment, running on the embedded processor of the unit under test, can easily deal with testing a display and the input components related to it. Efficiently testing the display requires careful crafting of the interface so that the user can move quickly and reliably through a complete test. As you can see, kDiagnostics includes a wide array of standard functions, both individual tests and complete test suites. We begin by initiating a standard Casio LCD display test script, selected from the Validation Assistant menu. We verify that some configuration switches are set correctly, and then we'll test the display itself. A standard color bar is displayed, and in this case it looks good, so we answer Y to the query. kDiagnostics then displays an alignment pattern, which looks good and shows that the LCD itself is correctly aligned. We display a standard user desktop, which also looks fine. Now we'll generate a more sophisticated pattern called a gradient, which in this case displays all gray patterns between black and white. The pattern should be a smooth white to black gradient. But whoa, this looks wrong. Since the display is incorrect, we'll indicate a test failure by entering N to the query. The test will remember this error but continues. Since LCD displays have an LED backlight, we'll test that it's working correctly by stepping through several intensity levels. We respond yes for each intensity level. This particular display also has a touchscreen, so the next step is a touchscreen test. We move our finger around the screen to make sure the touchscreen works everywhere, then hit the target to terminate the test. This system also includes a keypad, and it's important to verify that all of the keys are working correctly. We use the display to indicate when each key is pressed, and the test terminates when all the keys have been pressed. We've performed a very complete user interface test in less than a minute, but we still have the error we saw in the gradient test to investigate further. The failure mode looked like it could be a stuck bit between the processor and the display. Let's isolate the problem. First, we will initialize the display and determine which of the color bytes is bad. We first enter a specific green to black gradient, which shows a smooth gradient as we would expect. We then try blue to black, which also looks good. But the red to black gradient has an obvious problem. This indicates that something is wrong in the red byte of the display bus. Notice that the erroneous gradient shows 16 distinct bars, which gives us a good indication that the bad bit is the fourth one from the top of the red bus. Since the bad pattern is generally brighter than a good pattern, the most likely error is that the fourth bit is stuck high. We can enter commands directly into Validation Assistant, so we quickly confirm our assumption by executing a special Casio function which can simulate bit errors on this interface. First, we'll simulate the fourth bit being stuck low. Since the display output changes, we know the error is not this bit being stuck low, as we would have predicted. We'll now generate the gradient again and simulate the fourth bit being stuck high. Since the display did not change, we now know that bit 4 of the red byte is stuck at 1, and we can check for a loose connector or a bad solder joint. And we can even have some fun.
As you can see, special care is necessary to test a user interface system, but some elements of the system, such as the display, make other tests simpler and faster. For more detailed information, visit www.casio.com to download the User Interface Test White Paper.